Hello everyone. So today we will discuss about the intermediate value theorem in a numerical analysis paper. So what the method says that according to this theorem we can determine in which interval the root should lie. That means in numerical analysis you can face equation like x to the power 4 minus e to the power x equal to 0. Then determine the root or find the root in which interval it should lie. Okay, so here the question is in the form of a f of x, that means the function of a x equal to 0. So see here, intermediate value theorem says that the root of the equation, that means f of x equal to 0, lies in the interval a b if f of a into f of b less than 0. It is the condition, you should remember it that. So here the question is in the form of a f of x equal to 0. Then according to intermediate value theorem, the root of the f of x lies in interval a b. Condition is that if f of a into f of b less than 0. Okay, you should remember this formula. And see here, I am taking an example that is f of x equal to cos x minus x e to the power x. Okay, so this is the equation. Now put here f of 0. In case of x, put here x equal to 0. So cos 0 equal to 1 and 0 into something power is 0. So f of 0 equal to 1, which is greater than 0. Okay, so now is put f of 1. So for this use the scientific calculator, that is Casio 991 ES plus. So here it is on. Remember, in numerical analysis you should do all the problems in a radian mode. Okay, so for this press shift mode. Here is the radian in 4. So press 4 here. Again press shift mode. Here is the math 10 and the line 10. So you should do in the line 10, which is easier for you. So press 2 here again. Now it is in the radian mode. See here. Okay, r is there. Now I am putting f of 1 here. So see here, it is the cos under 1 bracket close, then minus 1, then here is the e to the power x. See here, this is the e to the power and it is in the yellow color, and it is the shift here which is also in the yellow color. So to write the e to the power of the exponential, press shift then e, that means e to the power 1, then a bracket close, equal to, then the values comes to minus 2.177979523, and which is less than 0. Got it? So I will tell you what's happening here. So see here, first this example, as the theorem suggests that the root should lie in the interval a b if f of a into f of b less than 0. Okay, so here f of 0 equal to positive value, that means 1, which is greater than 0, and f of 1 is negative, that is this value, that means which is less than 0. So you should write, since f of 0 into f of 1 less than 0, so by intermediate value theorem the root lies in the 0, 1 interval. Okay, so now see here, there is a method, that is Newton-Raphson method in numerical analysis. So by using the intermediate value theorem, we use this method. Okay, that is the Newton-Raphson method. So the formula for the Newton-Raphson method is xn plus 1 equal to xn minus f of xn divided by f dash of xn. Here f dash xn is the derivative of the f of xn. Okay, so where n is equal to 0, 1, 2, 3 up to so on. So see here, if the question is like the cos x minus x e to the power x equal to 0, then find the root correct to 3 decimal places using this method, that is the Newton-Raphson method. So how to approach this question? See here, you should write, and I already say you that the question is in the form of x, that means the function of x. So you should write f of x equal to the equation, that is the cos x minus x e to the power x. So now same thing, f of 0, put 0 in case of x, so cos 0 equal to 1, and it is 0 to the power something, 0 into something equal to 0, so f of 0 equal to 1. So see here, I am forgotten about that when you place the, when you write the f of 0, f of 1 until which value. So remember, f of 0, if you get f of 0 equal to 1, then f of 1 equal to something like 5, then if f of 2 equal to 7, or f of 3 equal to like 28, like this. If you get like this, then what the theorem is said that, what is the intermediate value theorem? According to this theorem, the root should lie in the interval a b, that is f of a into f of b less than 0. Okay, so if you do not get, that means you should get a positive and a negative value. Okay, adjacently. Okay, got it. So see here, if f of 0 equal to here positive and f of 1 is the negative, this is the adjacent value. So here in this question, the root lies in the 0 and 1 in open interval. Okay, so if you do not get like this, then you can put f of minus 1, f of minus 2 like this. Up to 4 or 5 places you should check, and in this value you can get your root interval. Okay, so if f of minus 1 like 5 and f of minus 2 equal to something like minus 2 point something, which is yes, in the 5 greater than 0 and minus 2 which is less than 0. So the interval should be like minus 2 comma minus 1. Okay, got it. So see here, in Newton-Raphson method, it is the easiest method first of all, and the formula you should remember that xn plus 1 equal to xn minus f of xn by f dash of xn. Okay, so see here, f of x equal to cos x minus x to the power x. Okay, so put f of 0. So in case of x, you should put 0, that means cos 0 equal to 1, and this would be 0. Then f of 1. I will tell you how to do this in the scientific calculator already. So put f of 1 in this equation, you should get this result. So as we say, since f of 0 and f of 1 less than 0, so by intermediate value theorem, the root lies in 0, 1. Okay. Now according to this method, what to do is you should calculate the derivative of the numerator. Okay, so f of x equal to this. So what is the dash? Here the f of x, then you should find out the derivative of the f of x, that is f dash x. So derivative of a cos x equal to minus sin x, and here is the minus as it is. Then derivative of x e to the power x. Apply the formula for UB, product rule. Okay, so x into u into dv by dx plus b into du by dx. Okay, so x into derivative of e to the power x is equal to e to the power x with respect to x as it is. Then here is the minus. I am directly writing the minus here. So minus e to the power x into derivative of x equal to 1. Okay, so derivative of the cos x minus x to the power x equal to this one. Got it? So we should write here. So by Newton-Raphson method, xn plus 1 equal to xn minus f of xn by f dash of xn for n equal to 0, 1, 2 and so on. So xn plus 1 equal to xn minus, now see what is our the f of x, that is cos x minus x to the power x, and this is the formula, that is the xn. So simply write xn in case of x, simply write xn in case of x. Okay, so that is cos, in case of x I should write xn minus xn e to the power xn. Got it? So divided by minus sin xn, that is the derivative part, minus sin xn minus xn into e to the power xn minus e to the power xn. So remember here, you should careful for the brackets here. Why I should tell you now. So see here, now what should do is, now I should now I will able to find out the root. Now taking x0 equal to 0.5, you can take as what is the interval of this, the interval of is 0, 1. Okay, so you can choose any value between 0 and 1. So any value, but if you use the mid value, the steps of the your problem becomes lower. Okay, the step will be reduced. Got it? So taking x0 equal to 0, we have see here x1. So see here in scientific calculator, I already tell you, you should use the radian mode in this paper, in numerical analysis paper. Okay, so for radian mode I already tell you shift mode. Here is the radian mode in 4, press 4, and always use the line 10. Okay, for better performance. So press 2, so it is in the radian mode. Got it? Now I will use the 0.5 because the 0.5 lies between the 0, 1. You can choose any value between the 0 and 1. Okay, so simply write, see here carefully, 0.5. Now store this value in a. So for storing the value in a variable like a, so press shift, here is the store, STO, store, so press store, then here is the a, store a. Okay, shift store a, that means the value is stored in the variable named as a. Got it? Now it is successfully stored in the variable a. Now S means all clear. Okay, got it? Now see here, our final equation is this one, for this equation. Okay, so see here xn, I am writing, I am telling you the n is 0, 1, 2, 3, 4 up. Okay, like this. Okay, so in case of xn, that means here is the x0. So in previous I stored the 0.5 value in a variable. Okay, so for writing a, simply type, here is the alpha, alpha is the this pink color, then a is in this color, pink color. Okay, so for a press alpha a, this thing a, that for xn, then put a minus here, then see here carefully, this is the outer square bracket and this is the inner bracket. Okay, this is the outer bracket, this is the inner bracket. So press two brackets here, 1 2. Then in the numerator part you have cos xn, and in case of xn I should write what a. Okay, so cos, then for a you should type alpha a, then bracket close, this is cos a, that means cos xn, then put a minus here, then again xn, alpha a, then e to the power xn. For exponential, this is in the yellow color, so press shift, which is in yellow color, shift e to the power xn, that means alpha a. So put a bracket here. See here, you should write, or you should type the bracket carefully, otherwise you got an error, that is syntax error. Okay, so here the a is closed, that means the xn is closed, not this bracket. So for this bracket you should type a bracket here. Okay, so finally our numerator part is done. Then put a division. Okay, then start the parenthesis, then minus sin x, put a minus here, then sin xn. Xn is alpha a, put a alpha a. Okay, then bracket closed, then sin xn is complete, then put a minus here, then again xn, so alpha a e to the power shift e to the power shift ln. Okay, so a e to the power alpha a, close bracket, then minus, okay, then shift ln e to the power alpha a, then put a bracket here. Remember, the bracket here is ending the xn. Okay, then for this parenthesis you should write the another parenthesis and this parenthesis over, and for complete the square bracket or complete the ending the bracket you should write the another bracket. You should carefully about the brackets, otherwise you got a syntax error. Okay, so now press equal. See here, our x1 value is this one. Okay, that is 0.5180260093. so see here, what should do, how to calculate the x2 here. Can we do, or can we place this method entirely in here, that means in xn, and xn is already stored in which variable? A. Got it? So for a lengthy process you can put this entire number in place of a, but for easy method I'll tell you how to do is simply store this value in a. Okay, so for this shift store, here is a, so press a, so the answer will be in a. Okay, now press the upper space. See here, this is the upper space. Now this formula, or this value now applied in this formula, okay, or in this equation. So now equal to, got it? So our x2 is 0.5177574.241. Okay, then again for x3, shift store a, upper space, equal to. Okay, so this is 0.5177573637. Okay, now again shift store a, upper space, equal to 0.5177573637. got it? See here, these two numbers are same. Okay, so when you get that, this here I am getting in x3 the number is this one, and x4 number is this one, but here is the x1 and x2, this is different from this. So when you getting the answer, you should match your answer in the upper part, which is exactly equal to this precedent value, that is x3 here. Okay, so what is the root here? So you can write the root corrects to if in question it is given that 3 decimal spaces, then the root you should write the root corrects to 3 decimal places each this one, that is 0.517. got it? So this is the root for this equation, that is cos x minus x to the power x. Okay, so today we will discuss about the Newton-Raphson method. Then in next video we will go for the bisection method. Okay, thank you.